Okay, so here's some steps for solving radical equations. First thing you want to do is isolate the radical. So in this example down here, I'd want to get the square root part isolated. Okay, so let's go ahead and do that. So on this particular problem, I would subtract 4 from both sides, right? And then I'd get square root of x minus 1 equals 1. Okay, so the next thing that I want to do is to I want to eliminate the radical. And the way I'm going to do that in this particular equation is by squaring. If I had a cube root, then I'd want to cube it. So you can square or cube, or you can raise it to the fourth or fifth or sixth power, depending on what type of a radical you have. So I'm going to say square or cube, but yeah, you could do, we're mostly going to just use square roots or cube roots, but depending on the problem, you might want to do something else. Okay, so squaring this on the left side, when I square square root of x minus 1, that's just going to become x minus 1. Okay, and then so 1 squared is 1. And then I want to solve this, right? So the next step is to add 1 to both sides, and then x comes out to 2. Okay, now it's possible that you will get extraneous solutions. So you want to check for that. So extraneous solutions are solutions that don't actually work in the original equation. Usually that's only going to happen when you get 2 solutions and one of them is extraneous, but a good habit is to just always check it. So yeah, once again, these are ones that an extraneous solution is one that doesn't work in the original equation. So for our check here, I'm just going to plug in 2 for x and see if it balances out. Okay, so let's start simplifying this here. I got the square root of 1. The square root of 1 is 1. I'm only going to use the principal root, only the positive root, right? So it's, yeah, the square root of 1 could be 1 or negative 1, but for the checks, only use the positive root. And then this does work, and then so I know that this is a good solution. Okay. All right, next problem, same kind of deal. Going to follow those same steps. Now, you could square this right now. But it would be kind of a mess because wouldn't be that big of a mess, but I'd have to square the 6 as well as the radical. So it's easier to isolate the radical first by just dividing both sides by 6. Then those cancel out, and I've got square root of x plus 10 equals 7. Okay, so now I will square both sides. So x plus 10 is going to equal 49. And then subtract 10, x should equal 39, and I just want to check to make sure that's a good solution. So I'll go ahead and do that, and sometimes you can kind of just do this mentally, and that's fine too. Okay, so I've got 6 times the square root of 49 is going to equal 40. Whoops, I don't know right why I wrote 44. That should have been 42. Okay, so square root of 49 is 7, and hey, this works because 6 times 7 is 42. So check, showed that that's a good answer. Okay. All right, next up. Now I've got a cube root. It's the same kind of deal, so I'd want to isolate the radical. Here the radical is actually isolated already, right? There's nothing else on the left side. But instead of squaring this, I want to cube it, since the index there is 3. Okay, so then that's going to give me 3x minus 4 is going to equal 2 to the third. 2 times 2 times 2 is 8. And then I just solve the equation. So add 4 to both sides, then divide by 3. Okay, and I still want to check this. In the original equation, checking this out, let's see, I've got 12 minus 4 in there. So the cube root of 8 is 2. This does work again. So far these are all good solutions. None of them are extraneous. Okay. All right, this one gets a little more challenging because we've got square roots on both sides of the equation. Sometimes if you had the same thing under both, if you had the same radicand, the same thing under both radicals, you could add or subtract the radicals together to combine them. But here, these aren't like radicals, so I can't do that. Okay. Also, I can't really isolate this. I could isolate this radical by dividing by 3, but then I'd have, the 3 over here. So I can't isolate both of these radicals. So that's just kind of out. So make sure one of them is isolated, and I'm just going to leave it as it is because the radical on the left is already isolated. Okay, and then I'm going to square both sides of the equation. Now here's the thing that I see people do a lot. They'll just square the radical part, but you can't do that. We got to square the whole equation. So the 3 gets squared as well. Okay, I'm squaring everything. So on the left side, it's just 8x plus 6. But on the right side, you got to think of this as you're squaring both parts. So I wouldn't usually write it out like this. I'm just doing this for explanation purposes. But I'm squaring the 3 and the root x. Okay. So then when I simplify this, I'm going to get 9x. A lot of times I see people just write that as 3x because they only squared the radical, but you got to square the whole thing. Okay. And then I just solve this. I'm going to subtract 8x from both sides. And then 6 is going to equal x. And that's my solution. Let's go ahead and check it. And since there's x's on both sides, I want to plug it in both places, right? Okay, I'm just using parentheses to show where I did the substitution. So let's see, this is 48 plus 6. And can't really do much with that. That's actually already in simple radical form, right? Because it would be 2 times 3, no twins in there. So let's see. Let's see if I can put the left side of, you could just plug these both into a calculator to check if they're equal, but without a calculator, I could put them both in simple radical form. So the right side's already in simple radical form. And then I'm thinking 6 times 9 is 54, so 6 times 3 times 3. Okay, and then, hey, there's twins, so one of the twins gets out, one doesn't. 6 stays in there, and then I can see that, yes, this does work. Okay, on the next page, same kind of deal. These problems are going to get a little trickier, though. So let's look at this next one. Okay, so first thing I want to do is isolate the radicals. So let's get that 2 on the other side. I'm going to subtract 2 from both sides. So square root of x plus 18 is going to equal x minus 2. Okay, so now we're ready to square. On the left side, I've just got x plus 18. Okay, now on the right side, very important, don't just square both terms because that's not what we do when we have a binomial squared. But that's the most common algebra mistake of all time. People will simplify that to just x squared plus 4 or x squared minus 4 or something. But remember, we got to FOIL that out, right? So first is x squared. Outer would be negative 2x. Inner is also negative 2x. So negative 2x and negative 2x is negative 4x, right? And then last, negative 2 times negative 2. Okay, so that's what I get when I multiply those binomials together. Okay, now I want to start cleaning this up. So I do have like terms, right? There's 2 different x terms. There's 2 different constants. So let's combine them. I'm going to move everything over to the right side since I've got more on the right side already. So I'm going to subtract x from both sides. And I'm going to subtract 18 from both sides. Okay, and that means those are going to cancel out on the left side, so I just have 0. And then I've got negative 5x minus 14. Okay, so now I've got a quadratic trinomial. So I want to factor this, right? I mean, you could use quadratic formula or complete the square as well. But when it's factorable, that's going to be the easiest way to solve these. So if this is factorable, it's going to look like that, right? I'm going to make a diamond problem. The negative 5 goes on top, negative 14 on bottom. Okay, and I'm thinking, how can I multiply to get negative 14? I could use a 1 and a 14, but that's not going to work. How about a 2 and a 7? A 2 and a 7 is going to work for negative 5 if the 2 is positive, the 7 is negative. So there's my winning combo. Okay. And now, use zero product property. Either this equals 0 or this equals 0. Okay, so now I've got these 2 solutions, and especially when you have 2 solutions like this, check them both because very often one of them will be extraneous. That's not always the case, but very often it is. So check them both. Okay, so let's go ahead and do that. I'll check x minus x equals -2 first. Let's try that out in the original equation. Okay, so plugging -2 in both slots for x, right? Both slots. Okay, and then I've got root 16 plus 2 equals -2. Okay, so it's tempting to simplify root 16 as -4 because one of the square roots of 16 is -4. But I don't want to do that. For the checks, only use the positive root. Okay, but if I use the negative one, it would actually work here, right? But I can only use the positive one. Okay, and then I've got 6 equals -2. Well, no, it doesn't. So that means that that this solution is no good, right? So I'm going to throw this one out. It's extraneous. Okay, it doesn't necessarily mean the other one does work. Usually that is the case, but you still would want to check it. Okay, and just to go back to this, just to point that out, always use the positive root. Only use positive root for checks. Okay. All right, so let's check x equals 7. Okay, so going back to here. Okay, using the positive root here, I've got 5 plus 2 equals 7. Well, that is true. 7 equals 7, so this one works. So there's my good answer. Okay, so another problem just like that down below. You can go ahead and pause this and try it out if you like. I'm just going to get to it. So first I'm going to isolate the radical by adding 3 to both sides. Okay, now that I've got the radical isolated, I'm going to square both sides. Okay, and then make sure you're thinking of this as x plus the quantity x plus 3 times itself, so that means we're foiling. So first would be x squared. Outer is 3x, so is the inner, so 3x plus 3x is 6x. And then last 3 times 3 is 9. Okay, I'm going to pull everything over the right side. Also, I like to keep the x squared positive if I can, just for factoring purposes. So I'm going to subtract 2x from both sides. And I'm also going to subtract 14 from both sides. So that I've just got 0 on the left side of the equation. Okay, and then I'll factor this. Okay, looking for two numbers that add to 4, multiply to -5. So 1 and -5 doesn't work, but -1 and +5 does. So that means my solutions are going to be, my possible solutions are x equals 1 or x equals -5. Got to check them though. Okay, so let's do those checks. Again, plugging this in both positions there. So that would be 16 minus 3 equals 1. 4 minus 3 equals 1. So this checks out. So this is a good solution. Let's check the other one. Whoops, that was -3 equals, and x was -5 here. Okay, so I've got -10 plus 14. Two minus 3 equals -5. I don't know why I wrote -2, but this should have been -5. Okay, so 2 minus 3 equals -5. No, it doesn't. that does not work. This one is extraneous. Okay. All right. So same kind of principle on this last problem. It's just that we have this written with a rational exponent. Okay. But keep in mind that's just a radical, right? That's another way to write a radical. So let's rewrite this as a radical. 4 would be the index. Okay, and then 3 is going to be the exponent, and you can put the exponent in either position, really. You can put the 3 inside the radical or on the outside. Either way, though, got to remember it's cubing the whole thing, because the quantity 2x is raised to the 3/4. Okay, so it's not just 2x to the third down there; it's the quantity 2x to the third. Okay, all right. So I want to isolate the radical. Let's subtract 2 from both sides. Okay. So now, since this is my index is 4, I want to raise this to the 4th power to clear the radical there. Okay. So let's see. This is going to just give me the quantity 2x to the third, and then 8 to the 4th. I don't know what that is off the top of my head. So let me check on my calculator. 8 to the 4th is 4,096. Okay. So I could take the cube root of both sides. That will definitely work right now. Okay. But be careful. It's that whole quantity. Okay. So it would be 2x equals the cube root of 4,096. That's one way to do it. You could also simplify this so that you don't have parentheses. But remember, you're raising 2 to the third and x to the third, because it's 2x times 2x times 2x. So this would be 8x to the third equals 4,096. So I'm going to do it that way. And then the next thing I'd want to do is divide by 8. So back to my calculator. That's going to give me 512. X to the third equals 512. Okay, and then I'm going to take the cube root of 512. Let's see. And that, okay, that's not going to come out. Actually, I made a mistake on my calculator. Cube root of 512 is 8. So that means x is going to equal 8. Okay, and as always, you really want to check this and make sure it works. Okay, so I've got, let's see, that would be 16 raised to the 3/4 plus 2 equals 10. So I'm just going to use my calculator to see what 16 to the 3/4 is. So 16 3/4 is 0.75, so I'll just write it like that. There's 16 to the 0.75. That gives me 8. And hey, this works, right? 10 does equal 10. So then I know my solution here is a good one. And I can move on. All right, and then on the last page, let's look at some radical inequalities. Okay, so here's a radical inequality. It's just an inequality where there's a radical. Okay, so we want to solve this. So you would solve this in the same way you would if it were an equation. So first thing you'd want to do is isolate the radical. So I'm going to subtract 3 from both sides here. Okay. One thing to watch out for, if you ever had to divide the whole equation by a negative or multiply the whole equation by a negative, then you'd want to flip the inequality symbol. But if you're just adding and subtracting, you don't need to do that. Okay. All right. And then I want to square this on both sides. So then I've got 2x minus 6 is less than or equal to 36. And then I'll add 6 to both sides. 2x is less than or equal to 42. Divide by 2. and then x is going to be less than or equal to 21. Okay, so that is part of my solution, but that's not all of it. Okay, so a lot of times people are going to just leave it at that. And that's a great start. That's where we need to start. But there's actually more to this, okay? Because the other step after we solve, we want to consider the radicand. All right, once again, the radicand is the part underneath the square root symbol. So whatever is under here is the radicand. Okay, the radicand cannot be negative. If it were negative, if I had a negative number under here, it would be imaginary, right? So the radicand can't be negative, and there's nothing wrong with imaginary numbers, but you can't graph them on a number line. Okay. The radicand can't be negative when the index is even. So remember, if there's no index listed, it's a square root, so that's an even index. If it's a cube root, it's actually okay to have a negative radicand, because the cube root of -8, that's not imaginary, because there is something raised to the third power that equals -8, right? It'd be -2. So it's okay if the index is odd, but if it's even, then we have to consider the radicand, okay? So my second step, I'm going to consider the radicand. Whatever is underneath the radical in the original equation, here that's the quantity 2x minus 6. 2x minus 6 can't be negative. So if it can't be negative, it has to be greater or equal to 0. It could be 0. Nothing wrong with having 0 underneath a radical. Square root of 0 is 0. But if you have a negative, then that's imaginary. So this is another way to say the radicand can't be negative, right? So now I'm going to solve this inequality. So I'm going to add 6 to both sides. Then I'm going to divide by 2. And now I've got both of these, okay? So I want to put these both together. So the way I'm going to do that on a number line is just list the two dividing points, 3 and 21, and now 3 is less than 21, so that should be the left of 21 on the number line, right? I'm not going to put all the ticks in between. You can just put the two dividing points, okay? And then I'm thinking, okay, x is going to be less than or equal to 21, so I've got a closed dot here, okay? And it would be going that way, and that's the answer I'm going to get from a lot of people on tests. But then also, x has to be greater or equal to 3. So that would be going that way. So they're going to meet in the middle. So it's anything between 3 and 21 with those two numbers included here, because it can be equal to either dividing point. Okay? So this is the big part to remember. The rest of it's pretty straightforward. It's just like an equation. Okay? All right, let's try another. So let's isolate the radical. So I'm subtracting 2. Then I'm going to square both sides. So x minus 3 is less than 9. Add 3. Okay, there's one of my dividing points, but let's consider the radicand. So this part can't be negative, so it has to be greater or equal to 0. And that's pretty easy to solve there, but you just got to remember to do it. Okay, so there's my two dividing points. So on my number line, I've got 3 and 12. Okay. Above the 3, this is a closed dot, and I'm going to be going that way, right? Because anything greater than 3, and then anything less than 12, but can't be equal to 12, so that's an open dot. So it's going to the left from 12, right? And there is my solution. Okay. Okay. Let's try one more. So let's solve this. So I'll cube both sides here because the index is 3. And 4 to the third power is going to be 64. Subtract 1 from both sides. Okay. So I've got x is less than 63. Let's consider the radicand. Wait a second. This is an odd index. So a negative number down here is no problem. That will not give me an imaginary solution. So when it's an odd index, you don't need to consider the radicand. So this is just my solution. So got an open dot, and anything less than 63, there we go. Okay, and that's it for today. See you next time.